Welcome back. In our previous episodes, we dove into some fascinating multimodal models, like ZSCOT, which gave us a peek into the world of zero-shot reasoning with text-based tasks, and LLM, which expanded on multimodal understanding by connecting language with visual data. Today, we're taking it a step further with Spirit LM. This model doesn't just stop at text and images, it goes right into the realm of speech. We'll see how it blends both text and spoken language into a single, unified system.
That sounds exciting. So, Spirit LM is like the next evolution, combining what those models offered but adding speech to the mix.
Exactly. It's not only about processing speech and text, but also about bringing expressiveness into the model. Unlike the previous models, Spirit LM integrates phonetic elements, pitch, and even style tokens, so it doesn't just understand words, it can capture the tone and mood, which is crucial for more natural interactions.
I see. And from what I've read, it seems like these additions make it much more versatile, especially for tasks that need emotional understanding or a more human touch.
You're spot on. That's what makes Spirit-ELM so important. It's built as a unified multimodal model that allows smooth transitions between text and speech. It's designed to handle expressive speech generation by utilizing these specialized tokens. Plus, it's equipped for few-shot learning across modalities, which is quite a leap for tasks like automatic speech recognition, text-to-speech, and speech classification.
So, it's flexible in terms of tasks, and it even introduces new benchmarks, right?
Yes, Spirit LM brings a sentiment preservation benchmark, or STSP, specifically to test how well it maintains the sentiment when switching between text and speech. This benchmark pushes the model to consistently carry the emotional tone across both formats. And to top it off, the developers have focused on safety and toxicity awareness in its output, which is essential for responsibly deploying a model that handles both speech and text.
That's a big deal, especially as more applications look to use these models in real-world interactions where tone and safety matter a lot.
Absolutely. So here's how we'll break down today's content. We'll start with an overview of Spirit LM's training approach and its unique interleaving method for speech and text. Then, we'll explore its capabilities in understanding and generating expressive speech, followed by a look at how it manages sentiment preservation. Finally, we'll discuss the responsible AI measures built into Spirit LM to ensure it operates safely across these different tasks.
Sounds like we're in for a thorough look at an incredibly versatile model. I'm curious to see how it all ties together.
Great! Let's dive into the first part, where we'll talk about the foundation of Spirit LM and how it's trained to handle both text and speech in one cohesive framework. Today, let's dive into the abstract for a project called Spirit-LM. This model stands out because it can mix and handle both text and spoken language in a single system. In simpler terms, it's designed to work well with both written and spoken inputs, and can seamlessly switch between the two.
So, it's a model that can deal with both text and audio as if they were the same thing? How does it actually combine them?
Good question. Spirit LM is built on a pre-trained language model with 7 billion parameters, initially only for text. They adapted it to also understand and generate speech by training it on a mix of text and audio data. Instead of treating text and speech separately, they used something called interleaving, where speech and text tokens are blended together as a single stream, with speech units mixed right alongside text words.
That's clever. So this blending approach allows it to understand both types of input at once, right?
Exactly. And what's more, Spirit LM comes in two variations: base, which handles standard phonetic speech, and expressive, which includes additional details like pitch and style. That way, the model isn't just converting words, but can also pick up on expressive tones, which is useful in capturing things like emphasis or emotion in spoken language.
Interesting. I guess expressive could make it better at understanding the mood or context in speech.
Absolutely. That added layer is particularly valuable for tasks that rely on tone, like sentiment analysis. Now, for both versions, text is encoded using subword units, specifically something called BPE, or byte pair encoding, which helps break down words into smaller parts that are easier to process. Meanwhile, the phonetic units for speech come from a speech model called Hubert.
So BPE is like giving it building blocks for words, and Hubert provides the sounds.
Exactly. The outcome is a model that can understand text contextually, like most language models, but also interpret the expressiveness of speech. This combination allows it to handle tasks across both modalities, from transcribing spoken words to understanding sentiment in both spoken and written formats.
I see. Does it mean Spirit LM can even learn new tasks with limited examples in both text and speech?
Yes, that's an important feature. Spirit LM is capable of what's known as few-shot learning, meaning it can pick up new tasks with minimal examples, whether the tasks involve text, speech, or even converting between the two. They tested this across tasks like ASR, which is automatic speech recognition, TTS, or text-to-speech, and speech classification.
Few-shot learning in both formats sounds powerful. Are these models and the code for Spirit LM available for people to experiment with?
Yes, they've made the model weights and code publicly available, allowing researchers or developers to try it out and see how it performs in various tasks. The openness really encourages more innovation and use cases for such multimodal models. To sum up, SPIT-LM is designed as a flexible model that merges text and speech seamlessly, making it versatile for many tasks where understanding both words and tones is key. All right, building on the abstract, let's shift into the introduction to understand why large language models have come to play such an important role in natural language processing. This section sets the stage for why Spirit LM was developed in the first place. First off, large language models, or LLMs, really became popular with GPT-3 in 2020. The idea is that scaling up models so they have billions of parameters opens up the ability to understand and generate language in a very flexible way. The bigger the model and the more data it's trained on, the better it can handle general-purpose language tasks. Does that make sense as a starting point?
Yes. So essentially, making models larger and training them on big data sets means they can handle language tasks better, right?
Exactly. And one more thing. Large models can learn new tasks with only a few examples. This technique, known as in-context few-shot learning, has made them adaptable to many new tasks without extensive retraining. Since GPT-3, other models have followed, like Llama, which showed that even smaller models can perform well if trained on more data for a longer time. This accessibility has been a real game-changer for research in NLP.
I see. So even smaller models can perform effectively if they have the right balance of data and training time. And that's allowed more researchers to work with these models?
Yes, exactly. Now, while text-based models have come a long way, researchers have also started exploring models trained directly on speech data, which they call speech-language models, or speech LMs. These models focus on specific speech-related tasks, like text-to-speech or automatic speech recognition. However, focusing too much on one modality, like speech only, can sometimes limit the model's ability to generalize, so there's a trade-off there.
Interesting. So speech LMs can be powerful for specific tasks, but if they're only trained on speech, they might not be as versatile as text-only LLMs?
Exactly. And this brings us to a major point the authors are making. Since text-only LLMs have become so strong, one way to generate speech has been to use pipelines. Transcribe speech to text using automatic speech recognition, then process the text with an LLM, and finally convert the result back to speech with text-to-speech. But there's a drawback. This setup often doesn't capture expressive speech as well. It can be quite flat in terms of tone or style.
So using separate models for each part in that pipeline limits how expressive the speech output can be. I guess that's a big downside for applications that need natural-sounding responses.
Exactly. To address this, Spirit LM aims to bring the strengths of text LLMs into the realm of speech by combining the generative power and knowledge of text models with the expressive abilities of speech models. The authors propose that by training an LLM on both interleaved text and speech, it can start to understand both formats and even generate responses in either text or speech, as needed.
That makes sense. By interleaving the two, the model would learn to handle both speech and text as part of one unified system. So Spirit LM could potentially do tasks that involve both types of input without relying on multiple models in the pipeline?
Exactly, and that's a great summary. This interleaving method allows Spirit LM to work cross-modally, handling comprehension tasks in both text and speech, and even prompting with few-shot examples in tasks like automatic speech recognition, text-to-speech, or speech classification. In short, it brings together the flexibility of text models with the natural expressiveness needed for speech tasks. All right, moving from the introduction, let's look into the previous research that set the foundation for Spirit LM's design. This section will cover what others have done in the field and how Spirit LM builds upon those advancements. First, there's been work on purely text-based large language models like GPT-3 and Llama, which have shown that language models can handle complex tasks when trained on vast amounts of text data. But what about models specifically for speech? Several models have been designed to work only with speech data. One example is Audio-LM, which uses different types of speech tokens to represent phonetic and acoustic details. Another is Vox-TLM, which combines speech and text but still largely treats them separately. Any questions on this approach so far?
So, Audio-LM and Vox-TLM are geared towards handling speech, but they don't integrate it with text at the level Spirit LM aims to, right?
Exactly. While they're powerful in their own way, these models don't focus on fully integrating speech and text into one unified model. They're either optimized for speech-only tasks or process each modality separately. Spirit LM, on the other hand, aims to unify both so that it can understand and generate across both speech and text seamlessly.
Got it. It sounds like Spirit LM is really trying to push beyond the limits of what these earlier models could do by treating speech and text as part of the same system.
Exactly. Another related model is TWIST, which takes a different approach by fine-tuning large text-based models for speech tasks. It still doesn't fully combine modalities but uses text pre-training as a base and then adds on some speech capabilities. Finally, there's Speech GPT, which fine-tunes pre-trained text models specifically for speech tasks like speech-to-text (ASR) and text-to-speech (TTS). Spirit LM builds on these by integrating both modalities from the start, rather than adapting text models for speech afterward.
So, instead of trying to adapt an existing text model for speech tasks, Spirit LM was trained with both modalities from the beginning. That probably makes it more naturally capable of handling both speech and text without switching models, right?
Exactly. This approach of training with both types of data gives Spirit LM the flexibility to manage and generate responses that involve text, speech, or both, making it a true multimodal model rather than one that needs extra tweaks to handle speech. In summary, previous models like Audio-LM, Vox-TLM, and TWIST have all contributed useful methods and approaches, but Spirit LM takes things a step further by fully integrating both speech and text data in its training. This allows it to naturally bridge tasks across these two formats without needing separate processes. All right, now that we understand the related work, let's get into how Spirit LM was actually trained. This section will describe the training recipe, including the different datasets, the tokenization, and the interleaving technique they used. Spirit LM is built on top of a text-based language model LLAMA2, specifically the 7 billion parameter version. To give it the ability to handle both speech and text, the authors used a continuous pre-training approach. This means they kept training LLAMA2, but added new types of data: text-only, speech-only, and combined speech-text datasets.
So, they didn't start from scratch but built on an existing model by feeding it both types of data continuously. What kind of datasets did they use for each modality?
Good question. For text, they used a subset of LMA's training data, focusing only on datasets relevant to speech, which added up to around 300 billion text tokens. For the speech side, they gathered over 460,000 hours from open-source datasets, which included a mix of languages and accents to ensure diversity. The speech data was tokenized into phonetic units using the Hubert model, providing a total of about 30 billion speech tokens.
I see. And what about the combined speech-text datasets? Did they have any special alignment for these?
Yes, exactly. They aligned the speech and text at the word level. This part involved taking speech datasets that came with transcriptions and performing additional alignment to ensure that speech units corresponded directly with text words. This alignment created about 110,000 hours of speech, paired with 7 billion speech tokens and 1.5 billion text tokens. They sampled all three types of data: text only, speech only, and combined speech text at roughly equal proportions to balance the training process.
So they really went for a balanced approach, making sure the model would see a mix of text, speech, and interleaved data during training. That should help the model generalize across both modalities better, I guess.
Exactly. And one of the key parts of this training recipe is the interleaving method they used. Instead of keeping text and speech separate, they interleaved them within the same training sequences. This meant that speech tokens and text tokens were mixed together at the word level, helping the model learn connections between the two.
That sounds like a smart approach. By interleaving them, it trains the model to switch back and forth between speech and text seamlessly. So Spirit LM would naturally understand both and handle cross-modal tasks better.
Yes, that's the idea. This interleaving makes Spirit LM well-suited for tasks that require cross-modal understanding, like generating text from speech or vice versa. The authors believe that this method creates a strong link between the semantics of speech and text, helping the model align spoken and written forms more effectively. All right, with the training approach in mind, let's get into how Spirit LM actually understands speech and text. This is where the model's ability to interpret and generate meaningful responses in both modalities really shines. Spirit LM was tested on several comprehension benchmarks, which are tasks designed to see how well it understands language. The researchers used both speech-only tasks, like SWUGGY and SBLIMP, and text-only tasks, like MMLU. For the speech tests, SWGGY looks at lexical or word-level knowledge, essentially checking if the model can recognize real words from made-up ones. SBLIMP, on the other hand, checks grammar by asking the model to identify sentences that are grammatically correct. Does that make sense as a starting point?
Yes, so it's like testing the model's vocabulary and grammar, but specifically with speech input. And then MMLU is used to test it with text?
Exactly. MMLU is a text benchmark that evaluates understanding across a variety of subjects, not just language structure. What's interesting is that Spirit LM performed well across both types of tasks, showing it can understand the nuances of both speech and text inputs. Additionally, they tried cross-modal tasks, where the model was given, say, spoken input and needed to generate text, or vice versa.
Cross-modal tasks sound challenging. I imagine it would be tricky to keep the meaning consistent when switching between speech and text.
That's right, and that's actually one of Spirit LM's strengths. By training with interleaved data, the model learned to handle these shifts naturally. For instance, in tasks like the story close test, the model was evaluated on its understanding of common sense and story structure, where the context was provided in one modality and the answer in another. The model successfully maintained coherence, showing that it understood the content beyond just words or sounds.
It's impressive that it can keep track of meaning even when switching modalities. So, it's not just matching sounds to text, but really understanding the underlying content.
Exactly. This multimodal understanding means Spirit LM can work on tasks like text-to-speech, speech-to-text, and even sentiment analysis across both modalities. Its architecture allows it to maintain expressive and semantic consistency, so it can generate responses that feel coherent and contextually appropriate, whether it's through text or spoken words. To sum up, Spirit LM shows strong comprehension in both speech and text formats and can handle tasks that require cross-modal understanding, which is quite unique in the world of language models. Moving forward, let's explore how Spirit LM tackles expressivity in speech. This is an essential part of the model, especially since capturing emotions and styles in spoken language goes beyond simple word recognition. Spirit LM includes a specific expressive version that incorporates pitch and style tokens on top of the standard phonetic tokens, which come from the Hubert speech model. These pitch and style tokens help the model capture more than just the words. It can interpret the tone and emotion behind the speech. For instance, pitch tokens help convey if someone is speaking in a higher or lower tone, which can signal excitement or seriousness. Does that make sense so far?
Yes, so by adding pitch and style tokens, the model can interpret the feel of the speech, not just the content. That sounds useful for understanding context, especially in expressive speech.
Exactly. They evaluated the effectiveness of this expressivity model by using a speech resynthesis task. Here, the model resynthesizes speech to check how well it retains the original's expressive style and pitch. Spirit LM Expressive was compared against other models like Encodec and versions using only Hubert tokens, and it performed significantly better at capturing the nuances of expressive speech.
So, it sounds like the expressive model does a better job at recreating the original emotion and style in speech compared to models without those extra tokens. That must make it more suitable for applications where conveying tone matters.
Right, that's the idea. Beyond resynthesis, they also introduced a benchmark called the Speech Text Sentiment Preservation, or STSP, to test how well Spirit LM can retain sentiment across both modalities. In STSP, the model is given prompts in either text or speech with a specific sentiment, like positive, negative, or neutral, and is expected to maintain that sentiment when generating responses, whether in text or speech.
That's interesting. So, if it receives a happy speech prompt, it should ideally produce a happy response, even if the response is in text.
Exactly. And Spirit LM Expressive outperformed its baseline in preserving sentiment in both text and speech outputs. This ability to carry over sentiment is crucial for tasks like customer service chatbots or virtual assistants, where maintaining an appropriate tone can make a big difference in user experience. Overall, expressivity modeling in Spirit LM allows it to go beyond simple speech recognition. It helps capture and convey the emotional and stylistic layers in communication, making it more adaptable for real-world, interactive scenarios where tone and emotion play important roles. All right, transitioning from expressivity, let's discuss the topic of responsible AI in Spirit LM's design. This part is crucial as it addresses how the model approaches safety, especially given the complexities of handling both text and speech inputs. The authors recognize that large language models, especially those that can generate spoken language, can sometimes produce content that's harmful, offensive, or biased. This issue is often referred to as added toxicity. In Spirit LM, they've put measures in place to evaluate and minimize any toxicity that might be introduced in the model's responses. They're looking specifically at toxicity that might not be present in the input but appears in the generated output. Does that initial focus make sense?
Yes, they're essentially monitoring if the model adds any harmful content on top of what was in the input. That's a good approach for safety.
Exactly. They used a dataset called HOLISTICBIAS for this purpose, which includes various speech prompts that have been shown to sometimes elicit toxic or biased responses in models. This dataset is used to see if the model produces more toxic language when generating responses in either text or speech modes. They also use specific toxicity classifiers, like MUTOX for text and ETOX for speech, to quantify these responses and see if there's any increase in harmful language.
I see. So they're using these classifiers to detect and measure any increase in toxicity between the input and output?
Yes, exactly. And they also compare Spirit LM to a pipeline approach that combines ASR, a text model like LLM, and TTS. This pipeline is sometimes used in place of multimodal models, but Spirit LM's unified approach helps reduce some of the expressive and toxicity issues seen in such multi-step processes. However, in some cases, especially in speech-to-speech tasks, Spirit LM did show higher added toxicity levels. The authors think this might be due to certain types of speech data used during training, but further work is needed to improve it.
So even though Spirit LM performs better in some areas, there's still room to minimize toxicity, especially in more expressive speech tasks.
Yes, exactly. In addition to reducing added toxicity, they're also mindful of the risks unique to speech models, such as impersonation risks, where the model could mimic voices or convey unintended emotions. They suggest using methods like watermarking, which could help detect any potentially harmful uses. They also stress that diverse training data is essential to avoid biases, especially when representing different demographics. In summary, the developers of Spirit LM are actively working to address toxicity and safety challenges by monitoring and evaluating harmful content, using classifiers, and suggesting safeguards like watermarking. Responsible AI practices are a central part of the model's development, helping to ensure safe and fair usage across both text and speech modalities. Now that we've discussed responsible AI, let's consider the limitations and broader impacts of Spirit LM. This part is key to understanding both the potential and the boundaries of what this model can do. SPIRET-LM, like other generative models, can be used for both positive and potentially harmful applications. For example, it could help with automated customer service by understanding and responding to both text and speech. But at the same time, it could also be misused for generating fake audio or misleading information in multiple formats. The model's developers have taken steps to mitigate such risks, like watermarking or reinforcement learning from human feedback (RLHF), to enhance safety. This makes sense as a precaution, right?
Yes, adding things like watermarking helps make sure it's clear when the content was generated by the model. And RLHF would guide it towards safer responses, right?
Exactly. These safeguards can help reduce risks, but it's also acknowledged that no model can be fully safeguarded against misuse. Another limitation is the challenge of accurately representing diverse voices and accents. In some cases, SPIRET-LM could generate responses with inconsistencies in accent or dialect, especially for underrepresented groups. They suggest that increasing the diversity of the training dataset could help address this bias.
I see. So if the training data better reflected all kinds of voices, the model would likely be more consistent in handling different accents and dialects.
Yes, that's the idea. And lastly, SPILM currently only performs well in English due to the scope of its training data. Expanding to other languages would require additional data and evaluation for those languages to ensure the model remains accurate and safe in a multilingual setting. This is an important factor to consider for broader usage in a global context. In short, while Spirit LM has impressive capabilities, the limitations around misuse, representational fairness, and language diversity are areas that need attention. These factors underscore the importance of careful deployment and ongoing development to minimize negative impacts. Now that we've covered Spirit LM's various capabilities and considerations, let's wrap up with the main conclusions from this work. The authors introduced SPIRET-LM as a language model that leverages the LLM-2 architecture to work seamlessly with both speech and text. By interleaving speech and text tokens during training, SPIRET-LM can handle cross-modal tasks, switching between generating text and spoken content fluidly. This setup also allows it to excel in both modalities, especially with tasks that require understanding or expressing emotions and tones.
So, the model's cross-modal abilities come from the way they trained it with interleaved tokens. That interleaving approach seems to be a major breakthrough in making it multimodal.
Exactly. And to evaluate its performance, they tested SPIET-LM on a mix of speech and text tasks, examining areas like comprehension, expressivity, and sentiment preservation. Across these metrics, SPIRET-LM showed promising results, particularly in tasks that involve both modalities, such as cross-modal sentiment preservation and expressivity.
I can see how this model could be useful in real-world applications that need flexibility between text and speech, like customer service or virtual assistants. But I guess they also mentioned some limitations in areas for future work.
Yes, that's right. They highlighted several limitations, such as the model's performance gap in purely text tasks compared to the original LLM-2 and its restricted capability to English only. They also see room for improvement in ensuring the model's safety, accuracy, and fairness, especially when handling diverse accents and demographics. Expanding these areas would be essential for broader applications. In essence, SPIRET-LM sets a strong foundation for a truly multimodal language model that works flexibly with both text and speech. While there's more work to be done, its approach offers valuable insights and tools for future developments in cross-modal AI. All right, that brings us to the end of today's discussion on SPIRET-LM. We've covered some exciting territory, from its unique approach to blending text and speech to the expressive elements it introduces with phonetic, pitch, and style tokens. And of course, the importance of safety and sentiment preservation in cross-modal tasks.
Yeah, I think it's fascinating how Spirit LM isn't just another language model, but one that can handle both written and spoken language while maintaining expressiveness. That's a pretty significant leap.
Absolutely. It opens up new possibilities for more natural, multimodal ATI interactions. And it's great to see the model not only achieving technical versatility, but also prioritizing safe and consistent content generation across formats.
For sure. I can see this being really impactful in fields like customer service, virtual assistants, and even content creation.
Exactly. And we hope you all found this as intriguing as we did. Thanks for listening, and stay tuned as we continue exploring the latest in AI advancements in our upcoming episodes.
Thanks, everyone.